Variables. Most of the time, a JavaScript application needs to work with information. Here are two examples. An online shop, the information might include goods being sold and a shopping cart. A chat application, the information might include users, messages, and much more. Variables are used to store this information. A variable. A variable is a named storage for data. We can use variables to store goodies, visitors, and other data. To create a variable in JavaScript, use the let keyword. The statement below creates, in other words, declares, a variable with the name message. Let message. Now, we can put some data into it by using the assignment operator equals. Let message equals hello, / store the string hello in the variable named message. The string is now saved into the memory area associated with the variable. We can access it using the variable name. Let message equals hello, alert, message, / shows the variable content. To be concise, we can combine the variable declaration and assignment into a single line. Let message equals hello, / define the variable and assign the value alert, message, / hello. We can also declare multiple variables in one line. Let user equals John, age equals 25, message equals hello. That might seem shorter, but we don't recommend it. For the sake of better readability, please use a single line per variable. The multi-line variant is a bit longer, but easier to read. Let user equals John, let age equals 25, let message equals hello. Some people also define multiple variables in this multi-line style. Let user equals John, age equals 25, message equals hello. Or even in the comma first style. Let user equals John, age equals 25, message equals hello. Technically, all these variants do the same thing. So, it's a matter of personal taste and aesthetics. Var instead of let. In older scripts, you may also find another keyword, var instead of let. Var message equals hello. The var keyword is almost the same as let. It also declares a variable, but in a slightly different, old-school way. There are subtle differences between let and var, but they do not matter for us yet. We'll cover them in detail in the chapter The Old Var. A real-life analogy. We can easily grasp the concept of a variable if we imagine it as a box for data, with a uniquely named sticker on it. For instance, the variable message can be imagined as a box labeled message with the value hello in it. We can put any value in the box. We can also change it as many times as we want. Let message equals hello, message equals world, / value changed alert, message. When the value is changed, the old data is removed from the variable. We can also declare two variables and copy data from one into the other. Let hello equals hello world, let message, / copy hello world from hello into message equals hello, / now two variables hold the same data alert, hello, / hello world. Alert, message, / hello world. Declaring twice triggers an error. A variable should be declared only once. A repeated declaration of the same variable is an error. Let message equals this, / repeated let leads to an error let message equals that, / syntax error, message has already been declared. So, we should declare a variable once and then refer to it without let. Functional languages. It's interesting to note that there exist functional programming languages, like Scala or Erlang that forbid changing variable values. In such languages, once the value is stored in the box, it's there forever. If we need to store something else, the language forces us to create a new box, declare a new variable. We can't reuse the old one. Though it may seem a little odd at first sight, these languages are quite capable of serious development. More than that, there are areas like parallel computations where this limitation confers certain benefits. Studying such a language, even if you're not planning to use it soon, is recommended to broaden the mind. Variable naming. There are two limitations on variable names in JavaScript. The name must contain only letters, digits, or the symbols $ and underscore. The first character must not be a digit. Examples of valid names. Let username, let test123. When the name contains multiple words, camel case is commonly used. That is, words go one after another, each word except first starting with a capital letter, my very long name. What's interesting, the $$ and the underscore can also be used in names. They are regular symbols, just like letters, without any special meaning. These names are valid. Let $= equals 1, / declared a variable with the name $let underscore equals 2, / and now a variable with the name underscore alert, $ plus underscore, / 3. Examples of incorrect variable names. Let 1a, / cannot start with a digit let my name, / hyphens dash aren't allowed in the name. Case matters. Variables named apple and apple are two different variables. Non-Latin letters are allowed, but not recommended. It is possible to use any language, including Cyrillic letters or even hieroglyphs like this. Let equals. Technically, there is no error here. Such names are allowed, but there is an international convention to use English in variable names. Even if we're writing a small script, it may have a long life ahead. People from other countries may need to read it sometime. Reserved names. There is a list of reserved words which cannot be used as variable names because they are used by the language itself. For example, let, class, return, and function are reserved. The code below gives a syntax error. Let equals 5, // can't name a variable let, error. Let return equals 5, // also can't name it return, error. An assignment without use strict. Normally, we need to define a variable before using it. But in the old times, it was technically possible to create a variable by a mere assignment of the value without using let. This still works now if we don't put use strict in our scripts to maintain compatibility with old scripts. // note, no use strict in this example number equals 5, // the variable number is created if it didn't exist alert, number, // 5. This is a bad practice and would cause an error in strict mode. Use strict, number equals 5, // error, number is not defined. Constants. To declare a constant, unchanging, variable, use const instead of let. Const my birthday equals 18.04.1982. Variables declared using const are called constants. They cannot be reassigned. An attempt to do so would cause an error. Const my birthday equals 18.04.1982. My birthday equals January 1, 2001, // error, can't reassign the constant. When a programmer is sure that a variable will never change, they can declare it with const to guarantee and clearly communicate that fact to everyone. Uppercase constants. There is a widespread practice to use constants as aliases for difficult to remember values that are known prior to execution. Such constants are named using capital letters and underscores. For instance, let's make constants for colors in so-called web, hexadecimal, format. Const color underscore red equals hashtag F00, const color underscore green equals hashtag 0F0, const color underscore blue equals hashtag 00F, const color underscore orange equals hashtag FF7F00, // when we need to pick a color let color equals color underscore orange, alert color, // hashtag FF7F00. Benefits. Color underscore orange is much easier to remember than hashtag FF7F00. It is much easier to mistype hashtag FF7F00 than color underscore orange. When reading the code, color underscore orange is much more meaningful than hashtag FF7F00. When should we use capitals for a constant and when should we name it normally? Let's make that clear. Being a constant just means that a variable's value never changes. But there are constants that are known prior to execution, like a hexadecimal value for red, and there are constants that are calculated in runtime, during the execution, but do not change after their initial assignment. For instance, const page load time equals / time taken by a web page to load */. The value of page load time is not known prior to the page load, so it's named normally. But it's still a constant because it doesn't change after assignment. In other words, capital named constants are only used as aliases for hard-coded values. Name things right. Talking about variables, there's one more extremely important thing. A variable name should have a clean, obvious meaning, describing the data that it stores. Variable naming is one of the most important and complex skills in programming. A quick glance at variable names can reveal which code was written by a beginner versus an experienced developer. In a real project, most of the time is spent modifying and extending an existing code base rather than writing something completely separate from scratch. When we return to some code after doing something else for a while, it's much easier to find information that is well labeled. Or in other words, when the variables have good names. Please spend time thinking about the right name for a variable before declaring it. Doing so will repay you handsomely. Some good to follow rules are: use human readable names like username or shopping cart. Stay away from abbreviations or short names like A, B, C, unless you really know what you're doing. Make names maximally descriptive and concise. Examples of bad names are data and value. Such names say nothing. It's only okay to use them if the context of the code makes it exceptionally obvious which data or value the variable is referencing. Agree on terms within your team and in your own mind. If a site visitor is called a user, then we should name related variables current user or new user instead of current visitor or new man in town. Sounds simple? Indeed it is, but creating descriptive and concise variable names in practice is not. Go for it. Reuse or create? And the last note. There are some lazy programmers who, instead of declaring new variables, tend to reuse existing ones. As a result, their variables are like boxes into which people throw different things without changing their stickers. What's inside the box now? Who knows? We need to come closer and check. Such programmers save a little bit on variable declaration, but lose 10 times more on debugging.